Wonderful, wonderful. Thank you so much for allowing me to present today. My name is Alex Brody, company is Brody Biomass, and we're part of a sister company, which is really the farming operation, which we call Brody Farms. Um, I called this the first commercial continuous biochar production facility because by commercial I mean that we're not grant funded or part of an academic research project. So that's pretty unusual. I think it's unusual to have a continuous biochar facility in the country. So what I'll try and do is explain how we got to where we are from being farmers and why we're here. And I think that it's also relevant to say that every biochar project will have its own key points as to why they're doing it and why they're getting into biochar. It may be because they want to get rid of a waste product, or it may be because they want a biochar for agriculture or for industrial use, or it may be a power generation opportunity, or more likely is going to be a combination of those. What all projects will have in common of this type is that they will be sequestering carbon. So starting with the pictures, the top picture there showing the church steeples of Brockham Village, and in the background, you'll see Box Hill. And the second picture will show from another of our farms where we are looking from Leith Hill across to Ranmore. And then the top picture of this slide is also from Leith Hill looking to another part of Ranmore. And what those pictures all have in common is a lot of trees. So we're in the heart of Surrey, some 25 miles from the centre of London, and Surrey is a little known fact, but Surrey is the most wooded county in England. So we have a lot of trees. So returning to now, and the picture at the bottom there of the barn is also highly relevant because that is an agricultural drying barn. It's a brand new barn we put up to facilitate alongside this project. So the family have been farming in the area since the early 1970s. My father started with a farm of 40 acres. We grew to 3 farms over 500 acres, plus another 50 acres or so of woodland. During the 80s and 90s, the farm expanded. We had arable and a breeding flock of sheep of about 1,700, and we employed about 5 people on the farm. Over the last 20 years or so, we've reduced the flock, don't rent land anymore, and we sold off the last of the sheep in 2000, and for the last 3 years we've been contract farming. The scale of the farm was just wasn't sufficient to justify the investment in the machinery required. But like most farms, we started to diversify, and in 2000 we did so by renting out barns, and the barns we rented were primarily to tree surgeons who were going out, chopping down, cutting down a lot of this wood. It was dead, dying, or overgrown wood, and they would bring it back to our site, and we had a timber yard there, and we started to process those logs and chip on the site. Historically, the wood has been chipped wood has been going to be aggregated on other sites and then to biomass boilers, and the brash, which is the leaves and the fines, have been in the past going to landfill, but also more recently, in recent years, for composting. But that will still be going, I think that currently has been going to Leicestershire. So over the years, we were screening the wood, processing it, and then moving it on. And I looked at this and thought, well, perhaps there's more we can do with this wood and possibly process it more locally. And in 2015, I reviewed it, and we looked at the renewable heat incentive, and I couldn't use the heat at all, and the carbon credits that could have been gained, I didn't believe in that so much. But it nagged at me, and I looked at it again in 2020, and I got a consultant report this time, and they came to roughly the same conclusion. However, they mentioned this word biochar, and that has taken me to where we are today. So looking at the project and the development, we had the feedstock, and I started to research the market, the technology, and read a lot of research papers, spoke to a lot of people, and did a fair bit of traveling around, bearing in mind that it was COVID, so there wasn't too much travel, but I was looking at the market potential. And I decided quite quickly that I didn't want to be in the batch market, doing batch kilns, but we wanted to be in the continuous biochar production. And that meant you're investing a lot of money. So I needed finance, and of course I had to run the financials, and initially we were looking at biochar, carbon credits, and electricity. I looked at getting grant funding, looked at UK Innovate grants, DEFRA grants, but I felt that, and I started two submissions but never completed them because as you go into it, the UK Innovate grants had already been granted to people like Blackpool Biochar, to Nottingham University, their demonstrator project, or indeed to Ricardo and their project. So I then turned to equity funding, and I was very fortunate to find a trading house and investment house that had already invested in a very sizable pyrolysis unit in Europe. But it was a different scale model. They were pyrolyzing rubber tires, and it was a different scale. But they liked this model I took to them, which was sort of medium scale and which could be replicated a lot of times. So the project, we built up some spreadsheets and cash flows, which concluded in that chart, which you can see to the right, which shows very healthy returns to investors over 5 years based on these cash flow streams. After sort of 9 months, we took it to the investment committee, but it got turned down in favor of some satellite technology. Which is very disappointing, but in hindsight, probably not a bad thing, to be honest. But it did hone my thinking. It did convince me that I wasn't barking up the wrong tree, and it really disciplined my thinking. So I was able to take that information to the bank and get a loan. It was a green loan, which we got, which doesn't give me any favorable rates of interest, but it does. I'm able to promote myself as having a green loan. And so there was a project there. At the same time, I was looking at, so I had to look at obviously the planning, the regulatory issues, and the planning application that we made was surprisingly easy, but you have to bear in mind that we applied as farmers. So going back in the story somewhat, in 2020-21, I removed a grain dryer that we'd had for about 40 years. It was no longer fit for purpose, and it ran off the electricity grid. So I took that down and I wanted to replace it. And so the barn, which you saw on the previous slide, we applied for planning permission as a grain dryer and agricultural grain drying facility. And we got permission, and the technology to dry that equipment uses the drying capability was through a pyrolysis unit. So we got the planning permission for 2 barns in the end. And the other regulatory concerns that we had to deal with or be aware of were the Environment Agency, and that's primarily around processing and holding of materials. And we're talking about quite a lot of material here, and the processing of that is a challenge. I got a T6 exemption, which allows us to process virgin wood. We already had that, but we will continue with that. And I got a U10 exemption that allows me to apply 50 tons of organic material per hectare on my land, and as long as it is improving the organic matter in that land. So I was happy that we would stay in line with all the regulations. The threats to the project were, could we ensure we had enough feedstock coming through and continue to come through? And the answer is yes, we can. The technology is and remains a challenge, but happily we have a unit that is working, and I'll go into that in a second. And the other challenge was, what is the market for biochar? Well, there isn't one really, not an established one. It's burgeoning and growing, but it's not yet developed. So I looked at, in terms of technology, I had looked at all the usual suspects that you will be aware of if you're in the sector. And we eventually decided to run with wood tech machinery. Wood tech we selected because they were, to be blunt, a little bit cheaper than everyone else, but critically, they were the only people who could talk me through from managing the feedstock to going through the pyrolysis and then what to do with the biochar in the end. So no one else could do that, and that set them aside, in my view. And I have to say that they've been absolutely wonderful in supporting and getting us to where we are today. So the process chart it looks complicated, but is terribly important. We take the wood chip in, and how you process the material is really critical to what comes out at the far end. So we screen the wood chip, and that falls into piles. I'll show you a picture on the next slide, but that goes to 8 mil and below, and 25 mil to 8 mil. And we screen that out, those two piles out. The wet fines, as I call them, the small stuff, goes to the compost site, and the chip that we want to send through to dry goes into the dryer, and then comes out through the dryer where it's screened yet again into 3 piles. The first pile is again small stuff, that's less than 8 mil, and then less than 20 mil, which is the stuff we want to pyrolyze, and the oversized wood chip goes for sale. So we've got a ready market for wet and dry fines and for oversized wood chip. And of course, we're also drying some logs and agricultural produce. And the drying comes from the heat from the pyrolysis unit. So we take the wood chip through, and it goes into the pyrolysis unit. And the dotted line there in the middle vertical line, everything to the left of that is really a farm operation, and everything to the right goes into biomass and towards the biochar, which comes out, and then we take the biochar, we either sell it or we mix it. So if I go to the next slide, we'll see pictorially what's going on. So the wood chip site on the left, top left, that chip goes to be screened. The smaller chip on the left-hand sort of bay there goes to the compost site, and the chip to the right is the stuff we're pyrolyzing. It then goes through the dryer and falls out into the picture on the top right, where there are 3 piles that come out there. At the top, I don't know if you can see the cursor here, is the auger, and it falls out of there. And on the left, we have the wood fines, the chip for pyrolysis in the middle there, and then the oversized goes out towards the end here, and then we've got an area for drying agricultural produce. From the middle bay here, this chip here, it comes into the, you can see the plan of the pyrolysis unit. That's a 4,000 square foot barn, and the wood chip gets entered into, we've got a hopper here, but it's a rotary arm bay. But the rest of the scheme is correct, and the wood gets pyrolyzed through the wood tech unit here and comes out into the biochar bay here, which you can see the picture of coming out here. The end bay here at the end, we reserve that for an ORC when we want to recover the energy at some stage. So from the biochar bay, it either goes direct into bags, or it goes onto a site up by where we're storing it beside the composting. So in terms of numbers and quantities, we're taking in about between 8,000 and 9,000 tons of wood chip per annum. We're losing about 30% of that to moisture, and that material gets through the screener. So approximately 1,000 tons is coming out here as wood fines, and about 4,000 to 5,000 tons is going through the drying machine. initially we were drying to 10 to 15% moisture content. We've reduced that down to between 5 and 10% moisture because we're getting a better pyrolysis at that level of moisture. So we're taking, so of the sort of the 6,000 tons that's going through here, we're about 3,000 tons of that, half of that is going to be pyrolyzed. And so so half the wood chip is going to be composted or for sale as wood fines, and 3,000 tons is going to be pyrolyzed. We expect to get between 600 and 900 tons of biochar, dry weight biochar per annum from the 3,000 tons of wood chip that's going through the pyrolysis system. So the theory is that let's say we've got 750 tons of biochar, we're hoping to get on our life cycle analysis a multiplier of say 2.5 times, which will give us anywhere between 1,800 to 200 to 2,000 tons of biochar per annum. And you can do the maths with your own figures on what you think you might get for carbon credits. But that is worth in sales anywhere from £250,000 upwards, we believe. The biochar sales, well, again, if we're talking about 750 tons of biochar, I don't know what value you put on biochar, but let's say the retail end will go for £1,000 a ton. That's obviously quite a lot of income from selling biochar. And then we've got wood chips and compost sales on top. That's the theory. The reality is, to the end of February, we had produced about 250 tons of dry weight biochar, and we had sold in this sort of in bags here about just over 20 tons of biochar. So less than 10% of the biochar that we had produced was sold, or has been sold. This picture here, the second from the top row, second from left, that's actually compost that we made last year from the brash and fines that we had collected, and that there's a very ready market for, and I've sold over 50 tons of that, and that pile has all gone now, and we're rapidly trying to make as much compost as we can, because there's a ready market for that. So we've been using the biochar on our own farm. I've got a massive ash trees that have got ash dieback, and here you can see the compost biochar that I've put on about 20 trees so far, and I'm sincerely hoping that that is going to help cure ash dieback. The next picture along, the last one on the right, the top right, is quite interesting because that is biochar that we put down as a cool bedding in a horse barn, and we're putting this wood chip on top, and the aim of that is to reduce, to mop up urine, reduce smells, emissions, and at the end of the year, that's going to be a supercharged compost, we hope. Now, of the 180 to 200 tons of biochar that I had to use on farm, I'm putting that into this. You can see this row here. This is 3 layers of biochar with 3 layers of wood fines. That's 120 meters long, with 2.5 meters high by about 5 meters wide. And this picture here is as it is today, with the wood fines on, and this is going to take us down the regenerative farming route. So I think that the key part of this message is that whoever's contemplating getting into the biochar world on this scale must have a use for it, because there is no established market at the moment for biochar. The projects that are away that tend to be up and running around the world, they tend to have some form of offtake agreement already, whether it's for industrial use or for farming use or whatever. But without us having the capability of taking this biochar on our own land, we would have a very big problem. But in terms of value to me, I think that this is probably for carbon credits it's worth probably about £60,000 of biochar there for carbon credits. I think that it will be worth probably about half that again for as the bottom line to my farm, in the sense that I can use less fertilizer, there'll be less pesticides. I should be able to qualify for some subsidy because I'll be increasing my organic matter, and I also have a project on to sell carbon credits as a farm on our journey to getting to net zero. But obviously, what I must not do, and we pays not to do, will be to double count the biochar that I've already claimed carbon credits on. Say the price of the carbon credit is for the biochar, the voluntary market is say £150 a tonne. In the agricultural market, you can sell carbon credits for about £30 a tonne at the moment. So big difference between the two. The picture on the left is our biochar that we're composting. There's a mix between wood fines here and brash, about 80%, 10% horse manure, and 10% biochar. The row at the back, the windrow at the back here has been piled up, but when we initially start the windrows, we start very low. It allows a lot of rain to get on there. As it gets wet, we pile it up and we manage that. And then when it gets drier, which hopefully it will at some stage in the near future, we will be putting a compost tea as a watering system here. And we've got now have 5 of these windrows. This is number 3. We're using a machine a unit called Compost Manager to monitor the composting process. And so what's of interest to people with this compost is that they know the provenance of it. It's got very little or no plastic in. And the unit records the composting conditions of each compost, and and we can record that to PAS 100 standards. So that is how we're managing the process so far. In terms of markets and sales, I don't want to talk too much about this because everyone have their own views, and the audience, I take it, is quite knowledgeable. But the obvious for agriculture, it's arable. There's plenty of research papers to demonstrate what the effect it has on yields. Livestock, the increasing amount of evidence that it's good for the livestock, reduces pathogens, reduces emissions. Horticulture, or everyone's looking for the peat-free compost. And then huge industry applications. As far as agriculture is concerned, we will be putting our biochar back onto our fields, and we'll just be monitoring for the effect on yield and in pounds and pence. So when we have that evidence, then we can use that and hopefully persuade other farmers to go down the same route as we are and take our biochar at some stage. I think the most interesting things in this list are the use of biochar as a filtration instead of an activated charcoal, and for land remediation. I've got a project on with Surrey County Council where there's a tributary to the Mole, which is on my land, which has been actually monitored for the last 5 years for water levels and flows. And we want to see whether we can use biochar along with leaky dams to hold up water and in times of heavy rainfall to stop flooding lower down the river. So that's the sort of quick summary. I hope that was interesting to people and hopefully informative to people who are seeking to get into the sector. I'm very happy to answer questions where I can.
Thank you very much, Alex. That's indeed interesting. I wasn't aware of growing biomass before, and I'm even in the UK, so it's very surprising how much you already did there. But great to see actually that there is a plant in operation, and I acknowledge that especially in the UK the market is very small. I mean, their market. Um, so you got a couple of questions already in the chat. The first one was from John Hoffmeyer. Can you tell us what the pyrolysis process is from WoodTech? What kind of machine it is?
Yes, it's a low oxygen uh, pyrolysis unit. It's pyrolyzing at about 700 to 800 degrees, so it's a very high temperature. And it's the biochar is in the unit, or it's got two. It burns with oxygen for a minute or two to take off the gases, and then the char sits on a grate for about a quarter of an hour. It's an interesting question because the we're we can push about 3 tons of biochar through per day, but it hasn't really been it hasn't been charring to a high quality. So we've slowed it up, and we're thinking 2.4, 2.5 tons per day is probably about the right um, rate. It's further complicated because initially we had a lot of dust going through the pyrolysis, and that caused all sorts of problems on the infeed and blocking augers. And it also, we think, threw around the pyrolysis process with the very temperature heat, and we weren't getting a complete burn, we don't think. But having taken out the dust early in the process now, and Woodtech have got since we've gone into production, they've gone into production with the biodynamic on their own farm, which is the Shropshire Council project. So they're now running the two systems in parallel, and we're starting to get much better data. They're putting the same feedstock going through, and we're able to compare the results. So we're still working to get consistent pyrolysis, consistent readings, to get a consistent biochar at the end of it.
Also, from what I know from WoodTech, so you, because Paul Anderson was also asking, it's kind of a partial gasification intermediate process system, I would describe it as. But you can look at the WoodTech site, so they have a very nice explanation of their technology in detail, if you want. Simon Longworth was asking, it's my understanding that the WoodTech uses liquid cooling, so dropping it into a water bath. So presumably your biochar is coming out at 60 to 70% moisture. Is that the case? And do you dry it afterwards?
Yeah, no, that is the case. And what we think happens is that by dropping it into the water, quenching it in water at the end, activates it to a large degree because it's pyrolyzing at quite a high temperature. And as you put it into the water, it clips open the pores, is what we think is happening. And it comes out at about 67% moisture. That's correct. And I quite like that, to be honest, because there's no dust flying around, and there's very little risk of any self-combustion. The last thing I want to be doing, to be honest, is breathing a lot of coal dust.
And, but are you drying it at some point, the
we're
biochar?
not, we're not at the moment, Christian. There hasn't been the demand for it. It is quite extraordinary. You saw the sort of picture of the biochar pile earlier, and when I take it out there, it's about 60. It can even be over 70%. And there was a time last September where it was dry for about 10 days, and the moisture content went down to between 30 and 40% naturally. And the other really interesting thing about that compost pile is that the water below that compost pile is crystal clear like mountain water. And my dog that goes running around there will always drink out of that water and not elsewhere, which is really interesting in itself. So it's and the other thing about that part of biochar is how long it retains the heat for. It's quite extraordinary, and you'll get little pockets of heat. Because my compost manager will also they've also set it up to test the water content in the biochar temperature, It's becoming very interesting. I'm getting a lot of data on this on the temperature and how long it will last for. So you can see why it's valuable as an insulation property as well.
Hmm. And because you mentioned the composting now, I think that's a very interesting one. Do you see, or do you already see that it speeds up or slows down the composting process in comparison to?
I don't know enough about it at the moment, Christian. I can't answer that.
So
What is interesting, what I can say is that 120-meter compost row, which is for our own use, is totally inert. There's very little activity going on there, and we're trying to work out why. Now, where we've got those other windrows, there's a lot of activity there, and the temperature goes up and down and all over the place. In that 120-meter, I still haven't worked out why, whether because we've layered it. It reacts. It's reacting totally differently to the other windrows. So again, I'm learning a lot as we go along. And the other thing I find about compost, everyone has their own ideas and what makes the perfect compost. So we're talking to vermicast people, frass people. I've got a specialist coming in to advise to make sure we're getting the right sort of nutrient contents in that compost. But I'm quite excited about the compost because there's a very big market for that, because what people are liking about the story is that the provenance, the material comes within 25 miles.
yeah.
We've asked the tree surgeons not to put their plastic mugs and cups in the section, so there's hardly any plastic at all in that material. Through the compost manager unit, I'm able to tell exactly how it's been composted, and I can give that report to anyone who wants to buy it. And we have been selling. I came across these organic growers at Groundswell last year, and they just can't get enough of it. And it's either I'm trying to work out either it's because it's very good quality compost, or I'm selling it too cheaply. I haven't worked out which one yet. But so we're rapidly and I've got 5 windrows now of that, and we're adding to it weekly almost. And I've already sold the first one, and then that's the easy bit. The difficult part is the biochar, to be honest.
Yeah, yeah. No,
Without an outlet for the biochar, it's very hard to justify this sort of enterprise. So I'm very lucky. I can, under the U10 exemption, I can put 50 tons per hectare on. I can take all that biochar for 5 years without worrying about it.
but I guess you don't want to if you don't have to.
Well, look,
Mm.
I'm very interested. I want to go regen ag on our farm. And the more I get into this project, biochar is a very interesting project. It gets far more interesting when I look back what I can do for it on the farm.
Mhm.
And then you start learning how dead my fields are. And you start looking at the microbe evidence in there. And it's taking us down a very different route. And I'm genuinely very excited by it as that we can actually improve the land with this. But at the end of the day, I need to, I've got to make money on this. I've already had my setback. Puro have changed their terms. I can now only sell in blocks of 1,000 corks. So I won't get the first payment from that until September. I was expecting to starting to get paid for that in March. So my cash flows have been affected. So, you had to adjust accordingly. So yes, no, we at the end of the day, we've got to keep an eye on the bottom line.
And so who's your credit certifier? Are you with Pure Earth or
We're registered with Puro. We're not yet up there. We're going through the LCA as we speak. And I'm using Extend as my brokers. And they're very helpful. So we're making progress there as we speak.
Okay, that's good. So Stora Enso was asking, what is your total volume in tons per year again? And have you experienced any problem achieving that volume? Or what is your current volume projection?
Well, I think we're going to settle down to 2.5 tons of dry weight per day. I think we'll be producing anywhere between 600 and 900 tons per annum. We've been off since the start. The downtime's been about 25% of the time. So the problems that we've had with it are the feedstock. The dust was a problem initially. We were pretty strict for 2 reasons. One, we started slightly later, so the the wood chip that we had decomposed slightly and got a bit dusty. Then with all the wet weather we've had, the screener drills were blocked up, so we were putting too much dust through into the dryer. But we've now adjusted after it comes out of the dryer, we put another grill of 8 mil or less, and so we're taking a lot of that dust out after the drying process before the product goes for pyrolysis, and that seems to have cleaned up the wood chip totally. And you can see in the wood tech unit there's a little pane of glass you can see, and the burn is a lot cleaner now. The dust is out, and I think that the dust was causing problems with the burn, and I suspect different densities, different temperature was all being thrown around, and you can see on the data that there's a lot of variation now. We've got much smoother lines of temperatures throughout.
Yeah, so let's hope that continues and you get a very straight running process from now on. There's a last question from Eero Liren. Have you tried to parallelize after composting, so basically your compost?
Very early on, and we've been asked to compost to paralyze a number of materials, and the answer is no. I think that to stand a chance of success, you need a consistent feedstock. You need to have it prepared to the same standard all the time, and then maybe you can succeed. Machines don't like change, generally speaking, and if you start putting different feedstock, different calorific values, different density values, I just don't think it's very sensible. And with all the trouble we had initially we were off for the first 3 months for 25% of the time offline, and that was 80% of that was because of the dust. I think either clogging up the infeed or actually not producing a particularly good biochar.
Yeah, I think it's sensible to not play around too much, especially before you know what the unit is doing. So thank you very much, Alex. We're a bit over time, so it was a very nice presentation. And if